Welcome to our video on production design and analysis of the machine tips assembly line. This is Zhang along with Xingyun and Julie. The purpose of this video is to show how our design was improved from its initial state, along with the suggestion on how to implement it further. To begin, we will be going over the product overview and the assembly line overview through a precedence diagram, followed by the initial workstation layout. Then we will talk about the problems that we encountered from the Design Lab 1 with suggestion on improvement. Finally, we will show a cost-benefit analysis on the improved design. There are 8 different parts needed to assemble the machine tape. Just for the convenience sake of this video, this is how we will call each part. Starting from left, either the lid or the cover, the stopper, the tape roll, the backboard, the clamp, and the 3 different screws are just referred to as the left-hand side, middle, and the right-hand side screw. In our assembly line overview, we have a precedence diagram to show the order in which this part should be assembled in. The tape roll should be placed in the backboard before putting in the stopper. This is because the stopper might get in the way when the worker is rotating the tape roll, which might slow down the process. Then, after placing the cover on top, the order of fastening the screw doesn't matter. The initial workstation layout was designed based on our precedence diagram and the client's demand. We have 2 workstations with 2 workers in each workstation. The workers in the first workstation have responsibilities to assemble the tape roll with the backboard, the right-hand side screw, the stopper, the lid, whereas the workers in the second workstation have to screw in the left-hand side and middle screw along with the clamp. The layout of the items in the first workstation was originally in 2 rows to make it easier for both workers to reach all of the bins. However, another problem arose from this layout as the workers started getting into each other's way and caused delay times. To avoid this, we created a new layout following the 5 S's: sort, set in order, shine, standardize, and sustain.
In this new layout, we have 2 identical assembly lines in which there are 2 workstations with 2 workers working in each workstation. The difference from the original layout is that with a double number of workstations, the workers are given more space and items to work with, as there are boxes of necessary items provided to each worker at his own workspace. There aren't any collisions between workers happening anymore. Then, we organized the item setups differently. Now they're sorted in the order in which they should be assembled, satisfying the first and second of the 5S: sort and set in order. This is how we standardize the work for all employees in the company, and the remaining 2 of the 5S are for those employees to maintain the working environment clean. Some problems we ran into in the first design are having deformed springs on the tape rolls and unexpected time delay due to poor assembling order of the middle screw and the clamp. We also had safety issues because of the tape rolls exploding rather easily. As to solve for the safety issue along with ease of handling and attachment, we will be presenting some new designs of the tape measure. Last but not least, there is still room to improve the design by speeding up with the fastening of the screws. Here comes our first problem. This tape roll has a deformed spring. And having a deformed spring makes it harder on the worker to put the tape roll in between the 2 plastic sticks sticking out of the backboard. However, with this, the plier, the worker doesn't have to fiddle around trying to place the spring in the right place. Depending on how the spring is deformed, it can make it harder for the worker to find out which part of the spring should be put in between the 2 plastic sticks. If the right part of the spring isn't put in, it can cause either the stick to break or the tape to not function. To fix this problem, we decided to add a mark on the correct part of the spring. Now the workers can manage to do their work without difficulty and time delay. Then another issue we faced came from the order in which the middle screw and the clamp was put in. The purpose of the middle screw is not only to hold the lid in place, but also the clamp. As you can see, if the clamp is placed on top before the screw, then it's hard for the worker because the screw is relatively short and is not stable. But if we place the screw on first and fasten it halfway in, the screw will be stable enough to be fastened even with the addition of the clamp, and the work can be done easily. Our third problem was the safety issue due to the tape roll exploding easily. When the worker is rolling the tape, he has to make sure to hold the tape tightly. As the edges of the tape roll are very hard and sharp, the workers can easily get a cut on their hands. The first solution we came up with to make up for the safety issue is to wear gloves of any sort like in this picture. Another solution we came up with is the metal clip idea, which takes care of not only the safety issue but also the ease of handling. As the process becomes easier for the workers to deal with, there will be an increase in the efficiency of the assembly line. Because we can't actually change the design of the product in reality, we use SolidWorks to demonstrate this. The red part shown in the model represents a metal clip with its main purpose being holding the tape in and avoiding the tapes exploding on the workers. The tape can still be pulled out in desired length for use because the red metal clip can be rotated around the tape roll. Also, the efficiency of the assembly line can be increased as the workers no longer have to hold the tapes tightly as they assemble, and their movements will become agile. Another part we found that could be improved for ease of handling was this. It's hard for the workers to get a grasp on the tape roll tightly enough to rotate it on top of the backboard because their fingers are cramped within such a small space. To improve this handling process, we came up with a new design of the backboard and the cover. The new design is on the left and the original design is on the right. We got rid of the wall on the backboard, making it flatter so that there's nothing getting in the way of the workers' hands when they're rotating the tape roll. However, we didn't get rid of the wall entirely. We left a small bit of it in the left-hand corner to satisfy the design for ease of attachment, which states that items should be clicked in before the worker lets go. In this case, the end of the tape roll is clicked in the small bit of the wall that's left over. Because we designed the backboard so flat, we had to redesign the cover. Not much was changed except that the wall that is attached to the cover got higher.
Out of the 6 tasks in the tape measure assembly line, 3 of them involve fastening of the screws. Rather than fastening the screws manually, using this automatic screwdriver from Black Decker, which has an RPM of 130, can speed up these 3 tasks and bring down the cycle time. This table shows a comparison between the screw fastening done manually versus theoretical calculation of it being done with an automatic screwdriver. The first column with initial time is the measured time of fastening the screws manually, and the second column is the theoretical time calculation of using the automatic screwdriver. As stated before, only 3 tasks involve the use of screwdrivers, so you can see the change in just the 3. The task times are approximately brought down to 1/10 of its initial time. The improvement of using automatic screwdriver from the initial design can be seen from these 2 tables. Because the screw fastening time is shortened so much by using automatic screwdriver, the tasks should be newly allocated between the 2 workstations. The new design can bring down the number of workers needed from 4 to 3 people, and also the cycle time from 20.59 seconds to 11.27 seconds. Now we will be presenting a cost-benefit analysis to show that this change is actually beneficial. The cost can be calculated by first calculating the total time needed. This is done by multiplying the demand by the cycle time. Then the total time should be multiplied by the number of workers and by the salary. This will give the cost of producing the client's demand. With the new design, the cycle time is cut by about half the initial time. Additionally, having one worker reduced gives a much lower cost in meeting the client's demand.